All right, I'm going to move on to the next slide. If you haven't done your attendance, make sure you do your attendance. Also, if you have not joined the Pear Deck, you need to make sure you join the Pear Deck because I'm going to stop sharing my screen right now. I've posted it in the chat, and I'll post it one more time for you guys to go to. All right, so we are doing lesson 1.5. It is force, strength, and velocity change. All right, force, strength, and velocity change. All right, so today you're going to be able to use a model to determine relationships between changes in force and velocity. So we're going to be using a simulation, and then we're going to be using a model at the end of class. All right, so we are going to review the definition of friction and then answer the questions on how friction affects velocity. Okay, so we read an article about friction on Monday. And so what I want us to do right now, if you have not put this in your digital notebook, is I want us to add this vocab word to our digital notebook. All right, so we've got the word friction. So friction is a force between an object and the surface it is moving over. Friction is a force between an object and the surface it is moving over. All right, so make sure you have that definition down. Friction is a force between an object and the surface it is moving over. I'll make sure to write that in our chat. All right, I put that in the chat if you get a little behind, so make sure you check the chat if you did not get it off this slide. All right, so what I want you to go ahead and do is go into this warm-up so you can click on this screen, and you're going to consider the two events and answer the questions. So imagine you push a book across an incredibly slippery surface. So it slides right across because there is no friction. Next, you push the same book across a rougher surface that exerts friction. All right, so those are your two events. Make sure you go in and answer those questions, and then it's got the definition of friction right there at the top. All right, I'm going to give you guys just a few minutes to do this, and make sure you come back to Pear Deck when you are done. Monday, right? If you read this article on Monday for homework, I want you to tell me anything that you may have found out, maybe something you already knew from this article. If you need to go back to the article and look at it, or if you think you remember what you read in the article, let me know something in our chat. All right, let me know something in our chat. All right, so if you want to pull up that article, you can. If there was anything that stood out to you in the article, maybe you annotated the article, you can go ahead and type that in the chat, or you can unmute yourself. All right, so Abby said the hockey puck was moving towards the goal and it kept moving for it to be able to be in the goal. So if Abby, have you never watched a hockey game? It's pretty cool. If you can skate, or if you can't skate, it's neat to watch them skate on the ice. But if we're talking about the hockey puck, what can you say about the hockey puck on that ice? What can we say about that hockey puck on the ice? Okay, so it had more speed. Could we say it had more velocity? Would that be a better way to explain that? Okay. Anybody else see anything interesting from what we read on Monday? Or maybe something that you already knew? Because I don't think friction is a new topic for us. All right, Krisha sent me a message and she said friction will act against an object and make the force act the opposite way, possibly. All right, so friction acts against the object. Kaylee said the ice will help it go fast. If you guys want to respond to everybody in the chat instead of sending me a private message so that others can see those. All right, so Krisha said friction will act against an object, and Kaylee said the ice will help the puck go faster. All right, so what I want you to think about. So we're kind of thinking about friction. Our article talked about friction. Our warm-up is talking about friction. So we're going to come back to this warm-up, and I want you to discuss how you responded, or let me know what you think happens to this velocity or to the velocity of the book as you slide it across a surface with no friction and a surface with friction. Okay, so go ahead on Pear Deck right here and respond to this question. What do you think happens to the velocity of the book if you slide it across a surface with friction and with no friction? All right, I'll open and share or show some responses here in a second once I see most people responding. All right, so if you slide the book without friction, you think it will not stop and it'll keep going. So with friction, you think it's going to slow down and eventually stop. Okay, so this person's saying kind of the same thing. It might change speed or have more velocity if All right, I think you're getting the two mixed up a little bit. So if you have friction and if you don't have friction, make sure you're kind of going back to that to our vocab word, or sorry, our definition of friction. Okay. What did we say about friction? What did we say about the force? All right, so this person is saying the velocity of the book with no friction doesn't change, but the velocity of the book with friction will stop. Okay. So with no friction, there's no force there to stop it, right? All right, so you're saying it will increase if the book is slid across a surface with no friction. But how does it increase? Okay, does it really increase or does it stay the same? You got to think about it that way. But the velocity will decrease if you slide it on a surface with friction, because you do have a force there, right? All right, so this answer looks really good, even if it is short. So with friction, the book would slow down or stop, but with no friction, the book would keep sliding, right? Because there's no force acting on it. All right, so I'm seeing a few misconceptions here. Some people are understanding that friction will slow something down, but others are kind of getting them reversed. Okay, so we got to make sure that we understand what exactly friction is. So if I'm going to go back to our definition of friction. And so right here we can see that friction is a force between an object and the surface it's moving over. Okay, friction is a force between an object and the surface it's moving over. So friction is going to act like a force. It's going to act in the opposite direction to either slow something down or stop something. Okay? Friction is going to act like a force that's going to slow something down or stop something. So that means it's going to act in the opposite direction. All right, so now we need to come back to this pod mission. And so this is kind of tying into what friction is, or a little bit about friction. And so we need to think about the pod mission because that is what this whole unit is about, this pod mission. And so outer space is mostly empty. So there's almost no matter in the huge space between stars and planets. Okay, that means there's no friction at all in outer space. Okay, there's no friction whatsoever. There's no matter between the stars and the planets. All right, that's why you guys see things like kind of floating around in space, because there's no friction there. There's no matter. Okay, so I'm going to move on. All right, so let's kind of talk about this lack of friction. All right, why do you guys think there's some lack of friction in space? Why do you guys think that there's no matter in space? All right, you can let me know in the chat. You can unmute yourself. Why do you guys think there's no matter in space? Okay. Addison sent me a message and she said because there's no gravity, which can affect mass. Perfect. So Shelby also said there's no gravity. All right, so gravity has a lot to do with the lack of friction in space. Okay. So let's go on. We're going to keep moving on because we've got to get to this activity. All right, so we are going to open up that force and motion simulation that we first looked at on one of the first days that we started this chapter. Okay, so we're going to do a few missions in this simulation. All right, so you guys will use the sim to build on your ideas about how stronger or weaker forces can cause different changes in velocity. All right. So we are going to conduct a series of sim missions that will make objects reach their targets at the specified velocity. So your challenge is to complete each mission by exerting a single force on the object. And so that force can be any size or direction. All right, so what you guys saw when we first looked at this simulation was this open explore mode. So we are on lesson 1.5, so we are going to go through these missions. Okay, we're going to go through these missions today. We may not get through all 8 of them, but we are going to try to get through 5 of them. So for each mission, you guys are going to use this data table to find the object's initial velocity. All right, so this is in Amplify. And once we get there, I will open up Amplify and show you exactly how all of this is laid out. I don't think we're going to do breakout rooms today. I think we are just kind of going to do this together because breakout rooms did not go as well as I wanted them to. And I don't think people got the table done. And so we are going to go over what this should look like and how we are going to do this. Because at one point I am going to let you do a few of these on your own. Okay, so for our first mission, I'm actually going to go into Amplify and do this in here instead of showing you my slides. I think it'll be a little bit easier for you to see. All right, so if I'm in Amplify, I'm on tab 2 right now, and you guys can go there here in a second, or if you would like to go there now, whichever one you would prefer. All right, so this is my simulation. You guys have seen this before. We've got objects with different masses down here at the bottom. We've got our targets, which are going to come into play today. Friction, you can turn friction on or off over here. You've got your build, you've got run and analyze up here at the top left. And then over here with these 3 bars, I can open up the different missions. And so today we are doing 1.5, so I'm going to first start off with mission 1. All right, I told you guys that the targets would come into play. And so right here you see that we have a target. Our mission, so we're on mission 1. Our mission is up here at the very top where it says to hit the target with a horizontal velocity of 2 centimeters per second by exerting a force only once. Okay, we want to hit this target with a horizontal velocity of 2 centimeters per second. Now, where our chart comes into play, if I'm back on Amplify, okay, I'm going to scroll down here just a little bit, and you can see this chart. Give me 1 second. I really wanted to delete this stuff. All right, you can see this chart. So my object's initial velocity. What is my object's initial velocity in this first mission? Zero, correct. Ethan said it's 0. So that means that it is not moving at all. Okay, so I'm going to go back to my simulation. This object is not moving. So the next thing I want to do after I'm in the correct mission, I want to click run. All right, after I click run, my goal was to hit this target at 2 centimeters per second. Okay, so what I want to do is I want to prepare my force. Okay, so you've got prepare force up here at the top right. Once I prepare my force, this bottom right is going to show me some arrows. All right, so I want to hit this target going to the right at 2 centimeters per second. So what I'm going to do is I'm going to kind of mess around with my arrows and see if this target goes into, see if this object goes into the target. All right, so I'm going to click this arrow 4 times. Let's see if it goes into the target. Yep, right past it. So if that happens, I'm going to go up here to analyze and see what's wrong, see why it's not working. Okay? All right, if you're looking up here at the right, at the top right, we're only doing one object. So object A, my horizontal velocity was 4. Okay, my horizontal velocity was 4 centimeters per second. We don't want it to be that fast, right? We only want it to be 2 centimeters per second. So I have a question for you. How many times did I hit that arrow to the right? How many times did I hit the arrow to the right? Do we remember? Not everybody jump at once. How many times did I hit that arrow to the right? Okay, Addison says 4. She sent me a message. Drew says 1 or 2. Augusty sent me a message and said 4. Abby said 4 times. Okay, I'm seeing a lot of 4s. So I'm going to go back. What I'm going to do is prepare my force, and I'm going to show you exactly what I did. You need to make sure that you're paying attention. All right, so I'm going to hit my arrow. 1, 2, 3, 4. I'm going to exert my force. This object is not going to go in to the target. Okay, I'm going to go back to analyze. Okay, good, Drew. That was the question that I was about to ask. Drew said that it's too much. Ethan said I need to only hit it 2 times. Perfect, you guys. I can see right here that my horizontal velocity is 4 centimeters per second, and I want it to be 2 centimeters per second. So I'm going to go back to run. I'm going to redo this whole thing. And what I'm going to do is I'm going to prepare my force, and I am only going to hit this arrow 1, 2 times. If this works out, this object should go into the target and it should kind of eat it up. There we go. Perfect. All right. So after you get done with that, you are going to go back into Amplify and to your table. Okay, so on my table, if my initial velocity was 0 and I put force on it, what did I do to my object? How did I change the velocity? Did I speed it up, slow it down, start it, stop it, or change the direction of it? Correct. So I started it. All right. It had an initial velocity of 0, so it was standing still. I had to start the object. Okay. Which way was my force? Which way was that arrow? All right. To the right. Now, this is where I did not go into detail. So the force strength. All right. If I go back to analyze, you guys will see down here, they call it the scrubber bar, and I'm not really sure why they call it a scrubber bar. But if I go back enough, you're going to be able to see the strength of my arrows. All right, so that is the strength of my arrow, that 20 right there. Okay, so when I go up into my table, all I'm going to put for force strength is 20. Now, you can also get the change in velocity in that analyze button as well. So if we look up here, the top right, okay, make sure you're looking at the top right. I know it's probably kind of little, but the change in velocity right here is 2. Change in velocity is 2 centimeters per second. Right, so 2 cm per second. All right, so we are going to do as many of these together that we can. We're going to stop in about 10 minutes, but I will continue to ask you guys questions on how to fill this table out. I'm not going to do breakout rooms because I don't think it went very well last class, and I think you guys will get a little bit more out of it if we do it together. All right, so let's go on to mission 2. Okay, so I would go up here to the top right, the top left. If you guys want to do this at the same time, then you totally can. If not, then you can just watch me, and I think you'll get just as much out of it. All right, so in our second mission, if we look up here at the top, we need to hit the target with a horizontal velocity of 6 centimeters per second by exerting a force only once. All right, so I'm going to go up here to run. I'm going to pause it because my object's moving. All right, how fast is my object moving? What is my object's initial velocity in mission 2? What is my object's initial velocity, guys, in mission 2? All right, 2 what? All right, 2 centimeters per second, right? We can't forget that second because centimeters is a measure of length. Okay, so 2 centimeters per second. That's why my object was moving at first. All right, so now what I want to do is prepare my force. If my object is going at 2 centimeters per second and I need it to go at 6 centimeters per second, what needs to happen? What do we need to do to our object? If my object is going at 2 centimeters per second, we need to get it to 6 centimeters per second. What do we need to do? All right, Drew said slowing it down. Krisha said speed it up. And then Drew changed his mind to speed it up. Okay, Abby, why are you saying we need to apply less force? All right, so if we need to speed it up, which arrow should I press? Which arrow should I press and how many times should I press that arrow? All right, so Krisha said to the right, and Ethan and Krisha both said 4. Shelby told me the right arrow. Abby said we got to speed it up 4 times. So I'm going to press the right arrow 4 times. 1, 2, 3, 4. All right, I'm going to exert my force and we're going to see what happens. Perfect. All right, so I'm going to go up here to analyze. I'm going to scroll our little scrubber bar down so that we can see the force of our arrow and we can see the change in velocity. All right, so we are going to go back to our table. What did we need to do to our object in order to get it in the target? All right, we needed to speed it up. All right, what direction was our force? Okay, our direction of the force was to the right. If I go back here, I have the force strength. So our force strength was 40. And then what was my change in velocity? Do you guys remember? If I went from 2 centimeters per second to 6 centimeters per second, what is my change in velocity? Good, 4 centimeters per second. All right, so I'm going to go back to my simulation. We are going to go to mission 3. All right, so now looks like we're going to the left this time, right? So our initial velocity, if you're looking at the table, is 5 centimeters to the left, okay? Initial velocity is 5 centimeters to the left. That's why these lines are a little bit longer. And so what we want to do is hit the target with a horizontal velocity of -2 centimeters per second by exerting a force only once. We want to exert a force only once, but we want to hit this target with a horizontal velocity of -2 centimeters per second. All right, how are we going to do this? What do we need to do to this object? Okay, so I'm going to go in, I'm going to run it, I'm going to pause and prepare my force. All right, we want to hit this at -2 centimeters per second. -2 centimeters per second. What does that mean? If we're going at, what do we say, 5 centimeters per second? 5 centimeters per second to the left. The reason that this is negative is because it's going in the other direction. So actually do not worry about the negative right now. We will kind of look at that a little bit later, but the reason that it is negative is because that means it is going to the left. Okay, if it's a positive number in this simulation, it means it's going to the right. So don't worry too much about the negative. Okay, so Krisha said, slow it down, question mark. She sent me a message. Okay, so we need to, okay, let's see. Maybe we do need to slow it down. What I'm going to do is I'm going to go back in here and prepare a force. And so in order to slow this down, which direction do I need to click, or which force do I need to click? The left or right arrow? Okay, so Krisha's saying I need to click the right arrow. Abby said the right arrow. What's everybody else thinking? If I need to slow this object down, in which direction do I need to press or go? If my object is going to the left and I need to slow it down, okay, so I need to press this arrow to the right. How many times do we think it needs to go to the right? All right, if our velocity, check right here, our initial velocity is 5 centimeters per second. We need to slow it down to 2 centimeters per second. We know that we have to slow it down. Okay, Krisha's saying 3 centimeters per second. How many times do you guys think I need to press this arrow? All right, I'm seeing a lot of 3s, so I'm going to press this arrow 3 times. 1, 2, 3. I'm going to exert my force, and let's see what happens. It stopped. Hold on. I accidentally went off of it. I paused my stuff. All right, so our target ate it up, right? So we slowed it down. Now, which way was the force? Sorry, different question. In what direction was the force? So which button did we press? All right, we pressed the right button, not 8. Press the right button. Okay, now let's go back and we're going to analyze this. I know I'm kind of going back and forth a lot, but this is what you would have had to do if you were doing it on your own. So our force strength right here we can see is 30, but what is the change in velocity? What's the change in velocity? If you can see it up there at the top right. Okay, if we went from 5 centimeters per second down to 2 centimeters per second, what was my change in velocity? All right, so if I went from 5 to 2 centimeters per second, my change in velocity is going to be 3 centimeters per second. All right, we're going to do this last one, and then we're going to move on to the next thing. Okay, so I'm going to open up our fourth mission. Our mission is to hit the target with a horizontal velocity of 0 by exerting a force only once. Okay, so 0. So that means, what do we want to do to this object? If we want a velocity of 0, what do we need to do to this object? Abby, we are not doing mission 5. What do we need to do to this object? If it's going to go to 0. Okay, so Ethan's saying we need to slow it down. Krisha's saying we need to stop it. Brandon, what do you think we need to do? Madeline, what do you think we need to do? Kaylee, what do you think we need to do? If the initial velocity is 5 centimeters per second to the right, and our mission is to hit the target at 0 centimeters per second, what do you think we need to do to this object? Do we need to speed it up, slow it down, start it, stop it, or change the direction of it? All right, so we need to somehow stop this object. All right, we need to get it from 5 centimeters per second to the right to 0 centimeters per second. Okay, so if we go back to our simulation, how many times should I press my arrow in order to stop it? How many times do you think I should press my arrow in order to stop it? Okay, Ethan's saying 5 to the left. Krisha, when you say 5 centimeters per second, you can't technically say that for how many times you want to press the arrows, but I do get what you're saying. We do want to press it 5 times. Okay, so we want to press this 5 times to the left. So what do you think happens if I press it 5 times to the left when it's right here? Do you think it's going to stop right here in this position? Okay, Addison's saying yes. Anybody else? If we press this arrow 5 times to the left, do we think that it's going to stop right here in this spot? All right, let's go ahead and see. What did it do? It stopped, right? So it did not get to our target just yet. So what do you guys think that we need to do in order to get it to stop in our target? Okay, Ethan says stop it on the target. So if I prepare my force and I let it kind of go, and I stop it here. Oh no, I need to rewind. Gonna let it go. I'm gonna stop it there. And then let's see if this works. So 1, 2, 3, 4, 5. It worked. Perfect. All right. So we had to stop it. The force direction was to the left because that is the arrow that we pressed. The force strength, if we go to analyze, If you can see that number right there, that number is 50. It's kind of hiding the 0. All right, so what was our change in velocity if we went from 5 centimeters per second to 0 centimeters per second? What was our change in velocity? All right, Drew said 5 centimeters per second, and you will be correct. All right, so there's a few more things that we are going to go over. I'm going to go back to our Pear Deck. We are going to skip through some of these slides because we did them together and we didn't have to go over these. Just give me 1 second. Let me find our slide. All right, so we've got what is called a modeling tool. All right, and we're going to kind of hit on this for just a little bit, and we will work on this together on Friday. So you won't have to worry about this. We are going to work on this together on Friday. But we are kind of going to start on it today. And so this modeling tool is going to allow you to visually communicate your understanding of force and changes in velocity. I will show you the video on how this works on Friday because I want us to get to a few more things today. Okay, so we will review more of this on Friday, so don't worry about this video. But we are going to put a few things down in our digital notebook before we leave. All right, so we have one more vocab word, and that is infer. And so infer means to reach a conclusion using evidence and reasoning. Infer means to reach a conclusion using evidence and reasoning. All right, I put that in the chat if you need to look at that for a little bit longer. This is another thing on the modeling tool, so we will do that on Friday. This is another thing we will do Friday. And we've got a key concept, okay? So this is what we've been going over the last 2 days, and now we are finally getting these key concepts down. So in today's slide, so for chapter 1, lesson 5 slide, it will have important information, and you can write this key concept down in that box. So a stronger force can cause a greater change in velocity. A stronger force can cause a greater change in velocity. Okay, I also put that one in the chat. A stronger force can cause a greater change in velocity. So the more force there is, the greater change in velocity there is. All right, so after that, we have our weekly check-in for lessons 1.4 and 1.5. Yes, Ethan, chapter 1, lesson 5. Okay, so we have our weekly check-in for lessons 1.4 and 1.5 in Canvas. Okay, if you guys want to, this is the same extension links that we had on Monday. I'm not sure if I actually showed you this, but I think I did tell you this last week that NASA is actually going on a mission to a certain asteroid, and this asteroid is called Bennu. And they are getting some samples from the asteroid, which is really neat because we are doing this unit at the same time that NASA is going and getting some samples off this asteroid. All right, so there's also a simulation on this website called PhET. And then PBS has some stuff on force and motion as well. All right, that is the end of the lesson. The only thing that you guys need to make sure that you do is the weekly check-in for lessons 1.4 and 1.5 on Canvas. Okay, I'm going to type that out in the chat so you don't forget. All right, that is all I have for you today, guys. Make sure you do that weekly check-in. If you guys have any questions, just let me know, okay? Bye, Lily. You too, Isaiah. Bye, Aiden. Adios, Ethan. Bye, Krisha.